We're asked to write the expression with only positive exponents. This negative means take the reciprocal of whatever I'm attached to. It's a little easier to see the reciprocal if you have a fraction, say, in this case, 5/7 to the negative 1. The reciprocal would be 7/5 to the positive 1. Obviously, I don't have to put the 1 here. It's understood to be there. But I'm just trying to emphasize it changed from negative to positive by taking the reciprocal of the fraction. If you have just a number, say 6 to the negative 2, this means you have 1 over 6 to the second, which is, but again notice the exponent went from negative to positive. So for 2x to the negative 4th, we need to take the reciprocal of this, so we end up with x to the 4th in the denominator, and this 2 just stays in the numerator. In this case, the negative exponent applies to the parentheses, so that whole set of parentheses is going to end up in the denominator, and the exponent will become positive. Now this 3, we can apply the power rule and send it into each value inside. Each of these exponents is a 1, so we end up with 1 times 3 to the third, and p 1 times 3 to the third. Usually you'll be expected to calculate this value. 5 to the third, and p to the third, you just bring that along. You don't really have to write these 1s. I was just trying to be explicit that you multiply the power times that exponent. Looking at this one, we can't just cancel out y squared and y squared because in the numerator everything is to be raised to the third power. So this exponent of 3 multiplies this exponent of 1, giving you 3. 3 multiplies 6 gives you 18. 3 multiplies 2 gives you 6. Denominator stays the same. 3 raised to the third power is 27. And I'll just bring the 9 over. We'll still have to simplify this. But with the x's, we can use the quotient rule. This is x to the first. So cancel that out. Subtract 1 from 18. You're left with 17. Cancel both of these y's out. Subtract 2 from 6. And you're left with 4. So we have x to the 17, y to the 4, and we have to simplify this. Divide by 9 leaves you with 1. Divide by 9 leaves you with 3. So we end up with 3x to the 17th, y to the 4th. This is over a 1, but we don't have to write that. Looking at this one, we have a negative exponent out here. We also have some negative exponents inside. There's different ways to proceed. I think my choice is going to be clean up inside the parentheses first. So I'm going to take this x to the negative 4. By taking the reciprocal, in effect, I'll just push it up across the line and I'll change the sign. This y to the negative 3, I'll push it across the line and I'll change the sign. So again, x to the negative 4 comes up to the numerator and becomes x to the positive 4. Y to the negative 3 drops down to the denominator and becomes y to the positive 3. Notice this exponent's still negative. I'm going to clean up what's inside. I can use the product rule to combine these two. We'll add exponents. Down here, we'll add exponents. So this becomes x to the 7, y to the 8, and this is still to the negative 3. So to get rid of this negative exponent, I'm going to take the reciprocal of this entire fraction. And now instead of a negative 3, this is all raised to a positive 3. And I have to use the power rule. I send the 3 in to each of the exponents inside the parentheses. So 8 times 3 is 24. 1 times 3 is 3. 3 times 7 is 21. And oftentimes, if you have 2 to the third, you're expected to change this to an 8. Anything raised to the 0 power is 1. Since the entire set of parentheses is to the 0 power, that's the answer. In this case, I cannot take this y to the negative 4 and push it down because it has to get raised to this exponent first. The parenthesis only applies to what's in the numerator, so that's why I need to get rid of the parentheses. So we'll use the power rule, send the 2 in. So 5 times 2 is 10. Negative 4 times 2 is negative 8. So now I can take the reciprocal of y to the negative 8, push it across the line, and change the sign. Same with the negative 5. Push it across the line and change the sign. So now we have y to the positive 8 and x to the positive 5. Now we can use the product rule. When you multiply, you add exponents. When you multiply, you add exponents. I have two sets of parentheses here, but they really aren't doing anything. This is a positive 1 in front of the parentheses. If I send it in, I'll get plus 4n squared plus 8n. So in this case, I can ignore the parentheses. I want to combine like terms. I have an n squared and an n squared. So I'll put my positive 4n squared right underneath. I have a positive 8n. I'll put that underneath here. And then I'll simply add vertically. So this gives us 6n squared. And it's positive. 12n, again it's positive. And 4n to the 5th, there's nothing to combine it with. The common practice is to put exponents in descending order. So we'll start with 4n to the 5th. The next one would be plus 6n squared. And finally plus 12n to the 1st. But we simply write 12n. This is correct, but this is in a better form. Again, the exponent should be in descending order. Now looking at this problem, we have a negative in front, so you can think of it as a negative 1 if that helps. But either way, you have to distribute this negative to each term inside parentheses. So this will give us negative 11n to the 4th, negative 5n to the 6th, and a positive 12. So our original expression, so I'll just put each of these terms underneath the like term, n to the fourth. So we have a negative 11 n to the fourth. That's taken care of. Negative 5n to the sixth will go right here. That's taken care of. And finally this 12. So that leaves us with a negative 4. Signs are the same. We add and keep the sign. That's 20n to the fourth. And here the signs are different. We'll subtract. We get 2n to the sixth. So here we're to find the product. Even if they hadn't told us that, we have a term in front of parentheses. There's nothing within here that we can combine. So to get rid of these parentheses, we have to send in negative 7x to the sixth to each term. So this will give us a negative 14 x to the sixth times x to the fourth gives x to the 10th. Negative 7 times positive 10, that's negative 70. X to the sixth times x to the third is x to the ninth. For this problem, we have two terms in front of the parentheses. So each term here is going to have to multiply each term here. 2x times x gives us 2x squared. 2x times this positive 9 gives us positive 18x. And then this 12 has to multiply each term. So 12 times x is 12x, and 12 times 9, positive 108. When you have a pattern like this, a binomial times a binomial, they'll say FOIL. That was the first terms, the outer terms, the inner terms, and the last. It doesn't matter what order you do this in, but that's a way to be systematic and make sure that each term multiplies each term. Here we can combine these two like terms. So we'll have 2x squared. Signs are the same. We add and keep the sign. And 108. Now here we're supposed to square this. You cannot use the power rule and just send the 2 in to each term, because unlike this case where we could use the power rule, that is, we sent this exponent to multiply each exponent inside the parentheses, here nothing's being added or subtracted. Here we have two terms being added or subtracted. It doesn't matter. If they're added or subtracted, you cannot use the power rule. This exponent of 2 applies to the parentheses. That means you have two sets of parentheses. And inside each set of parentheses, you have n plus 12. And now we'll follow the pattern we just did up here. N times n. N times 12. 12 times n. And 12 times 12. And now we can combine these two like terms. So that'll give us 24n. And this just comes down. In order to simplify this rational expression, it's probably best to rewrite it to show what it really means. This 5x to the sixth applies to each term in the numerator. So again, this 5x to the 6 applies to each term. And now it's ready to simplify. So for the coefficients, divide by 5, divide by 5. And for the exponents, whichever one's smaller between the 6 and the 7 is the one that's going to get canceled out. So cancel this out, subtract 6 from 7, you're left with a 1. Looking at the next term, divide by 5 leaves you with 1, divide by 5 leaves you with 3. You have x to the 6 and x to the 6, so effectively each cancels the other out. And then over here, divide by 5 leaves you with 1, divide by 5 leaves you with 2. You have x to the 5th, x to the 6th. Whichever exponent is smaller is the one that is going to cancel out completely. Subtract 5 from 6, and you're left with 1. So we have 8x. Bring down this negative. You have 3 but no variable. Bring down your positive. And you have 2 over x. Now looking at this problem, you can't just write each term in the numerator over x minus 8 and simplify it. You could do that here because nothing in the denominator was being added or subtracted. You just had a single term. Here you have 2 terms in the denominator. So you're going to have to do long division. It's a bit more complicated than the long division you're accustomed to, but it actually does follow the same pattern. So a quick refresher, if you have 162 divided by 3, you say how many times does 3 go into 16? 5 times. And then you would say 5 times 3 is 15. You would subtract. You bring down the next digit. And then you repeat the process. How many times does 3 go into 12? 4 times. You would say 4 times 3 gives you 12, and you subtract. If the result is 0, you stop. And you could check this. You could say 3 times 54 is 162. So to do this calculation, again, we're going to follow this pattern, but it is going to look a little bit different. You focus on the first term. X goes into x squared x times. And x times x minus 8 gives you x squared minus 8x. And just like up here we subtract, but here when you subtract you have to apply that to each term. So effectively you change that sign and you change this sign. X squared minus x squared is a 0. You don't have to write it. Over here, signs are different. You subtract, keep the sign of the larger. And just like up here, you bring down your next term. Now you repeat the process, focusing on just the first term How many times does x go into a negative 5x? Negative 5 times. So negative 5 times x minus 8, that'll be negative 5x. Negative 5 times negative 8 will be plus 40. And you have to remember that we're subtracting this, so you'll change each sign. This gives us a 0, and this gives us a 0. And just as with the long division that you're accustomed to, you can check your answer multiplying this times that. We can check our answer here as well. So x times x, x times negative 5, negative 8 times x, negative 8 times negative 5. We can combine these two. And we have exactly what we started with. But just to be clear, the result of this division is x minus 5. We have another division problem. And again, we focus on the first term and the first term. The pattern I used in the previous example is I said, how many times does 5x go into a negative 15x to the third? But thinking of how many times this divides in is probably more complicated than just thinking, what times this will give me this? What do I multiply 5x by to get negative 15x to the third? I multiply by negative 3x squared. So negative 3x squared times 5x minus 2. Negative 3x squared times 5x gives us negative 15x to the third. Negative 3x squared times negative 2 gives us plus 6x squared. And remember, we're subtracting this, which means we change each sign. This gives us a 0. Signs are the same, we add. Bring down the next term. And now we repeat the process. Focusing on the first term here and the first term here. What do we multiply this by to get this? Negative 2x. So we put negative 2x right here. And when we multiply negative 2x times 5x minus 2, negative 2x times 5x, negative 10x squared, negative 2x times negative 2, plus 4x. And remember, we're subtracting, so we change these signs. That gives us a 0. Signs are the same, you add. Bring down your next digit. Well, in this case, your next term. And you repeat the process, focusing on the first term and the first term. What do I have to multiply this by to get this? A negative 2. So that would be a negative 2 times 5x minus 2. So negative 2 times 5x, negative 10x. Negative 2 times negative 2, plus 4. And remember, you're subtracting, so you change these signs. That gives us a 0, and so does this. So this is our answer. You could check it. If you multiply the divisor times the quotient, you'll get the dividend. I'll go ahead and check this, but I'll just show it in fast motion. This is what we started with. So again, this is the answer. Now looking at this one, again the exponent applies to whatever it touches, so you have 7 times 7, which is 49, and this negative just drops down. Bring down this sign, and here the 2 applies to the parentheses. So you have 2 sets of parentheses, each with a negative 3, and the result is positive 9. Signs are different, you subtract, keep the sign of the larger. To simplify this expression, notice we have y to the 0 power as well as this set of parentheses to the 0 power. Anything to the 0 power is 1. So we have 8 times 1 plus 1 minus 4 squared, that's 4 times 4, or 16. So 8 times 1, certainly that's 8, plus 1. Signs are different. Subtract, keep the sign of the larger. Here they're asking us to express the answer in exponential notation. So I'm not supposed to calculate negative 5 to the 7th, fortunately, because that would be a very large number. This might look a little confusing, but it's the same as if I had x to, well, it's very similar to if I had x to the 4th times x to the 7th. That would give me x to the 11th. If the bases are the same and you're multiplying, you add exponents. This is the product rule. So here the bases are the same. I add exponents. The reciprocal of 6 to the negative 1 is 1 over 6 to the positive 1. I don't have to write that, but I will in this case. Just to be explicit, bring down this negative. And the reciprocal of 3 to the negative 2 is 1 over 3 squared. Notice the exponent's positive now. So what we have here is 1/6 minus 1/9, because 3 squared is 9. Obviously, we need common denominators. And we end up with 1/18. Looking at this one, we've got a negative exponent out here, just one negative exponent inside. Y to the 0, well, y to the 0 is 1, so I'm going to pretty much just ignore that because it's being multiplied. I think I'm going to take care of this negative exponent first. So the reciprocal of everything in the parentheses is simply 1 over everything in the parentheses. Since I've taken the reciprocal, we change from a negative exponent to a positive. So I've taken care of this negative exponent, but I still have to worry about this one. To take the reciprocal of z to the negative 4, in effect, I just push it up across the line. So I'll have z to the 4th and now I can multiply each exponent by the 2. So 4 times 2 is 8. You have to be careful with this negative 5. It's in parentheses here. The 2 is outside the parentheses. So you need to think of it as in the parentheses. And 2 times 3 is 6. I've kind of run out of room going down, so I'll go sideways. We have z to the 8th. This gives us 25. And x to the 6th. Given that we have negative exponents here and here, I could take the reciprocal of each variable that has a negative exponent. But in this case, I think it's going to be easier to just multiply. When we have like bases, we can add exponents. So that's what we'll do. Starting with the negative 4 and the 9, that's just multiplication, so you get negative 36. P to the negative 5 times p to the 1. When you multiply bases, you add exponents. Negative 5 and 1 gives you a negative 4. Looking at the r's, you have like bases, so you add exponents. Negative 2 and negative 4 gives you negative 6. And now for each of these variables with a negative exponent, I'll take the reciprocal. So this will leave us with notice the exponents are positive once I put them down in the denominator. For 41 and 43, we're to write the number in standard form, that is, without exponents. So 7.6 times 10 to the 4th is really a number that's 4 decimal places bigger than 7.6. So you move the decimal 4 places. You'll need zeros to hold these places. $76,000. Both of these refer to the same value. It's just that this is written in standard form. This is written in scientific notation. For 2.1 times 10 to the negative 5th, well, that's really 2.1. And this times 10 to the negative 5th means this is smaller by 5 decimal places. And again, you need zeros to hold those places. You can put a leading 0 if you like. So again, this number and this number mean the same thing. It's just this is in scientific notation, this is in standard form. Notice if you have a positive exponent, you're talking about a big number. If you have a negative exponent, you're talking about a small number. Now for 45 and 47, we're to write the number in scientific notation. So to put a number in scientific notation, you always have one digit in front of the decimal. I'm going to drop the trailing zeros, times 10, and then I have to figure out what exponent to put here, so a person could take this value and get back to this value. Well, what did I do? I moved the decimal from here 1, 2, 3, 4, 5, 6, 7 places. I have to tell a person that they need to move it back 7 places if they want to get from here to the original number. So again, it's a positive exponent. We're talking about a big number. And finally for 47, again, to write it in scientific notation, it's one digit in front of the decimal, then times 10, and with my exponent here, I'll tell a person how far they have to move this decimal to get back to the original number. Well, to get the decimal here, we moved it 1, 2, 3, 4, 5 places. You need to show a negative 5 places. So again, in effect, it's a negative exponent if you're talking about a small number. It's a positive exponent if you're talking about a big number.